Now more of them are going to take calcium from the blood and lower your blood calcium levels back to where they're supposed to be. So, stimulate more osteoblasts, we're going to produce more, again, with the word more, bone. And as a result, we're going to decrease blood calcium to normal. We're going to stimulate osteoblasts. We are going to produce more bone. Again, leave a space, because there's a hormone that controls all of this. We're going to talk about that hormone in a little bit. All right? So, do you understand now why you have to understand this, you have to understand that, to understand that? But what's nice is that you have to understand these two things to understand this, but in understanding this, it reinforces that and that. So as you study one, you're studying for the other. As you study for the other, you're studying for the one. It keeps on getting reinforced, 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 reinforced. All right? So what we just drew here, here is this. That's what we just drew it. It's under hormonal control. I just haven't told you what the hormone is, although it's in your notes. When we get to it, we're going to add it to the story. All right? Are we good? Now what? We're going to spend about 30 seconds on this. I know that Lecture Receiver talked to you guys about this. We're going to talk about it next semester, specifically hematopoiesis, hemopoiesis. These are two interchangeable words. All that means is the production of something called a corpuscle. A corpuscle is a red blood cell, a white blood cell, a platelet. Okay, that's what that means. I'll concentrate on red blood cell. This is all I need you to know. Red blood cells and white blood cells and platelets are produced in your red bone marrow. You guys already knew that. What other kind of bone marrow do we have? Red and yellow. Yellow is made up of fat. There's another place to store fat in your body. Most of it is underneath your skin, but there are other places fat is located. That's not where red blood cells, white blood cells, and platelets are produced. Yellow bone marrow has nothing to do with hematopoiesis, hemopoiesis. Red bone marrow does. And all I want you to know is that it's red bone marrow. We won't have to worry about any of this stuff. We'll talk about that next semester. Is this. I want you to know that in an adult bone, that's where red blood cells are produced, and white blood cells are produced, and platelets are produced. Now, I know I have long bone in there. There's not a whole bunch of red bone marrow in long bones, but I assure you that it is present. It's kind of present on the ends. It loses a lot of the red bone marrow that it had originally, but it's still there. That's a vomit question. I promise you that's a vomit question on the exam. That's straight. Tell me where the red bone marrow is and where these red blood cells, white blood cells, platelets are produced. That's all it's going to be. I promise. All right? End of story for that. More on this next semester. Now what? So, we talked about bones, osteoblasts, how they make bone, how they make bone cells. I'm going to show you how your bones get longer. I'm going to show you how you grow. So you're born a certain height, and by the time puberty is over, you've grown to a certain height. How did that happen? Your femurs got longer. How'd your arms get longer? Humerus got longer. Long bones got longer. Those are the only kind of bones that can get long, right? The only kind of bones that can get long are long bones. The only kind of bones that grow in length are long bones. The regular bones do not grow in length. Long bones do. So I'm going to show you how that happens. And the reason that they grow in length is because they have a growth plate, an epiphyseal plate. And so we have this picture here, although we're going to draw it. All right, so we're going to draw a long bone. And in that long bone, I'm going to show you where the growth plates are, although I think you guys already know that. But you might not know about the 4 regions of the growth plate. So we're going to draw a long bone. It doesn't matter which long bone this is. It doesn't matter. Okay, so there's our long bone. This is the epiphysis, right? Epiphysis, diaphysis, right? We know all this stuff. At least we should know it very, very well by this point. In between the epiphysis, I'll just label it with E, and diaphysis is where the growth plate is, or at least it is initially. Eventually it's gone. So there's our growth plate. I'm not drawing it to scale, by the way. It's not really that big compared to the rest of the bone, but we need to write some things in there. We're going to write the numbers 1, 2, 3, and 4. Put the number 1 next to the epiphysis. So, number 1, 2, 3, and 4. Those are 4 different regions. We're going to do the same thing at the other end of the bone. 4, 3, 2, 1. Again, 1 is next to the epiphysis. 4 is butted up against the diaphysis. Okay? And so now what we're going to do is that we're going to magnify this. We're going to take the growth plate and we're going to magnify it. And we're going to put the names of these 4 different regions of the growth plate. And again, let's make sure that we know that that's the growth plate. Made up of cartilage cells, otherwise known as chondrocytes. You guys know that as well, I'm going to assume. So we have our 2 growth plates here. That's where the bone's going to grow. Actually, the bone grows right here. This is where bone is deposited. Right there. Right there. That's where bone is deposited. Not on the epiphysis side, on the diaphysis side. All right? So we have regions 1, 2, 3, and 4. We have 4 different what are called zones. All right? We have the zone of resting cartilage. And then we have zone number 2. That's the zone of proliferation. Then we have zone number 3. That's the zone of hypertrophy. And then we have zone number 4, the zone of calcification. So it's 4 distinct zones of the growth plate. And different stuff is happening in each of these zones. And so what we're going to do is we're going to talk about what happens in each of those zones. What we're going to do is we're going to take these words right here, and we're going to draw a picture. So if you want to number that in your notes, 1, 2, 3, 4. All right? So let's talk about what happens in each of these zones, and let's see how our bones get longer. Let's see how you get taller. Let's see how your arms got longer via this process that we're going to discuss. So we're going to draw the growth plate again, except now we're going to magnify even more. We're going to see the individual cells. Now, as we go through this, I'm going to draw the zones one at a time, but I want you to understand that all 4 zones exist to begin with. All right? All 4 zones are present. Okay? So, zone number 1, again, the zone of resting cartilage. So we'll put here, we'll put the number 1, and we'll put resting cartilage. And I'll put up here the letter E for the epiphysis because that's what's there. The zone of resting cartilage. Well, I can do that. Put cells, those circles are cells, and randomly arrange them. It's like if you took a whole bunch of cells in your hand and just kind of threw them against the wall. They are randomly arranged in the zone of resting cartilage. Okay? Now, they have a job. There's a couple of things that I need you to be aware of in this particular zone. What's happening with these cells? Number 1, they anchor the growth plate to the epiphysis. So, anchor growth plate to the epiphysis. We don't want the growth plate to be moving around. We want it to be set in place. So it's kind of glued in place by the cells within this area, and the matrix that surrounds them is more what's gluing them there. But that's what's happening here. It's just sitting. All right, we need it to sit in place, because if it doesn't, then the bone's not going to grow straight if it doesn't sit where it's supposed to sit. If it starts to shift, the bone's going to be all kind of jagged. It's not how you want your long bones. You want your long bones to be nice and smooth, okay, as they grow. All right, so anchor the growth plate to the epiphysis. What's another thing that you need to be aware of? They're dividing. The chondrocytes are dividing. They're going through mitosis. Okay? Now, and again, I want you to again understand that all 4 regions exist at the same time. We're just drawing them one at a time so that we're clear as to what's going on. As these cells divide, they're going to push downward into the next region. So these cells, as they divide, are going to push downwards. All right? They actually do give rise to these other regions, these other zones. But again, they just all exist at the same time. And so now that brings us to zone number 2, and that's the zone of proliferation. If you proliferate, that means more of something is present. And that's because of the division that's occurring. So we have division that's occurring here. Now something else is going to happen. And you need to draw them like this, please. These cells that were randomly arranged are no longer randomly arranged. Now, as they enter this particular area, this new zone, signals occur that cause the cells to arrange in columns. So now they're ordered, they're not randomly arranged. So what do we need to know that happens in this particular zone? Number 1, mitosis continues to occur, okay? So chondrocytes are still dividing. So they continue to divide. As they are entering this particular zone, they arrange in columns, as we can clearly see in the picture. A third thing happens that you need to be aware of is that they're going to start to calcify. We've already talked about calcification, right? What did I tell you calcifies? Osteoblasts calcify, right? They calcify when osteoid and hydroxyapatite mix together, right? That's what causes calcification. Chondrocytes are going to do the same thing. So chondrocytes are going to produce 2 things like the osteoblast does. Slightly different though, all right? But very similar. Calcification begins. And underline the word begins because zone number 4 is called the zone of calcification. I don't want you to think that that's where it starts. It doesn't. That's where it ends. Where it starts is in the zone of proliferation. How is that going to happen? Well, again, the chondrocytes have to produce 2 things in order for this to occur. It's not called osteoid, we just call it collagen. Most of what osteoid is collagen, but it isn't truly osteoid. All right? The next thing that's going to happen is the production of something else that's similar to hydroxyapatite, except it's not called hydroxyapatite. It's called proteoglycans. So proteoglycans, that's where the calcium is present, within the proteoglycan. Like hydroxyapatite has calcium. Proteoglycans have calcium. Chondroitin is a type of proteoglycan. You can go to Meijer right now and buy it off the shelf if you want to. They tout it as something that helps your joints because it's present in the joints. Some studies it works, some studies say it works, some studies say that it doesn't. All right? Anyway, doesn't matter. Proteoglycans is like hydroxyapatite, collagen, like osteoid, are going to mix, and this cell, the chondrocyte, is going to be encased in this crystalline structure just like the osteoblast was. It's no different up until this point, okay? Except slightly different stuff that's causing the calcification. All right? So 3 things that you have to be aware of in the zone of proliferation. Now what? As these cells in the zone of resting cartilage divide, as these cells in the zone of proliferation divide, they're going to continue pushing down. Everything just gets pushed down. So now we have these cells in the zone of hypertrophy. You guys know what hypertrophy is? It means to get bigger. Muscles, if you have muscles that go through hypertrophy, they get bigger. If you have a thyroid gland that enlarges, it's going through hypertrophy. Okay, anything can get bigger in the body. We call it hypertrophy. Okay? We're going to draw cells here that get bigger. They're still in columns, just draw them bigger. Give yourself a visual. So we have these cells now in this particular zone that are growing. They're getting bigger. They're still, these are all chondrocytes, guys. These cells here, these big cells, used to be one of those. Understand that all those dividing cells in that first zone are just being pushed down, pushed down, pushed down, pushed down. Okay? So, these cells in the zone of proliferation used to be these cells. These cells in the zone of hypertrophy used to be these cells in the zone of proliferation, which used to be these cells. As they divide, they just push down and go into the next zone and do what they do in those other zones. All right? So what do we need to know here? 2 things.